Okay.
Okay, just to recap for a moment, we looked at a system concept that we thought had pretty good potential to help us solve this video problem that we were given. And the potential here was to try to figure out, as best we could, what is the value of the intercept? What is the tactical geometry advantage? And we did, in fact, come up with the means to calculate that, as you saw. We didn't list the actual equation out there. That's a fairly straightforward direction angle function equation. But it is a real live equation. It is being used today in various aspects of the fighter mission. We tried to look at that from that perspective. Why did the pilot go into a left turn? Why did he pull 7.2 Gs? Is that right? Was that on the video? 7.2 Gs. At that rapid rate. What was the point of the aspect? Why was he trying to achieve that kind of aspect? Okay, and then at the end of that maneuver, what was his antenna train angle? Which is, obviously, it was a fairly large antenna train angle. Why did he go that far? So we're trying to come to grips with that. And what we have here, what Graham showed you, was an idea to capture the tactical geometry advantage, which is the thing that we decided, remember, this morning that we're going to focus on, which is task 6.1.1, analyze intercept geometry, right? So we're beginning to analyze it. The next order of business now in our fairly comprehensive study here, we think, is to come up with some notion of function allocation. We've described a candidate function, basically, in the previous section. Now we need to come to grips with this very difficult area called function allocation. Who does what? Is it done by the man? Is it processed by the man? Is it processed by the machine? Is it blended? And why are we assigning this function to this portion of the system? It's called function allocation. It's been attempted in the past with variable success. We're going to come up with a couple of ideas here, throw them out, discuss them to see if we can come to grips with this difficult area. What we're trying to get at is we've got a functional description of the system. In our case, it was the tactical geometry assessor. Who does that? And why? Okay? Kind of an important question. We do this by looking at the function and requirements allocation process. The function should capture whatever expression we use to describe the function. It should capture the essence of the mission and the tasks. And there's two things we want to do with this function once we have defined it and once it becomes real in our minds. We want to allocate that function generally and specifically to a component or a processing module in the system somewhere, and we want to specify that function. And we want to relate that function across to another function too, and there may be an interface we have to specify too. We need to come up with some kind of allocation strategies now. What is our allocation? What's a good allocation strategy? Man does things better, machine does things better. The FITS list, anybody familiar with the FITS list? Been around for 20 years, I guess, right? What's our allocation strategy? What's a good allocation strategy? All right, let's explore that for the moment. Remember, allocation is, what is function allocation, just for a moment? The function allocation is we are allocating this function, which is to ascend the mountain to the man, right? We've decided that the man is performing this function, correct? We could have assigned it to a machine and built a gondola. But for some reason, we wanted the man to climb the rope. Okay, well, we decided to do that, and obviously there was good reason to do that, I suppose. All right? So that's the kind of the response to the demands. We have defined what the mission demands are now because we've completed our analysis, and we have then trying to figure out how we're going to respond to these mission demands and who's going to do this work. In this case, we saw that the man was doing the work. Or another way of stating that is if we're designing automatic systems, who does what? And over here we see that we have an automatic system that is confusing the crew because he's not sure if it's for him or for somebody else. So function allocation gets to the heart of the issue, which is, what is the level of automation that makes sense now that in this day and age that we can automate lots of things, right? We can automate a lot more things today than we could, say, 20 years ago. All agree with that? So now we need to have some kind of a strategy, some kind of logic, some kind of rationale for automating these various functions. We were talking about that during the break, right? We were talking about, auto land systems, right? Why are we automating the landing function? Is there a good reason? Can we audit that back to a justifiable and defensible position, right? And hopefully that's what we want to do. Because we're a crack tiger team, we are going to do that. Okay, we're going to be able to audit that back and prove to the customer that our allocation strategy, to the best of our ability, makes sense. Okay. So we're going to come up with an allocation model that is shown here using some cartoons. The first order of business, though, is to make sure we know what are mandatory assignments. So A is a mandatory assignment. We may decide culturally that the man will always pull a trigger, okay? So that's a mandatory assignment. Even if we could automate that, we would decide that no, we got a man in the loop, the pilot's responsible for that final decision. We are going to not automate that function. Okay, so that's a mandatory assignment. And that's easy, right? Now, the more difficult things, and the other thing that is not too difficult is obviously things that cannot be technically automated. Okay, and we explored that this morning when we talked about type 1 decisions and concept application. Those probably can't be automated in the foreseeable future, all right, to any successful extent. So those kind of fall out, and they fall into the crew assignment area, okay, or that bucket. The other ones fall into what we call candidates for system processing or candidates for automatic processing. Now, this becomes a little bit more difficult to deal with. So let's look at those candidates. How does one begin to deal with those functions that are candidates for automation? Should we, for example, automate everything that we can? What do you guys think? Give me some thoughts. Yes? Yes, we should. All right. Why? Why should we do that? Automatic systems are more dependable. All right. What about the man in the loop? What is he doing?
You're offloading the man to concentrate on only the absolute critical functions.
Okay. And we should define what those might be, right? Okay. All right.
Only those things that he can do uniquely.
Let's put that model up there. All right. Let me just spend a few more seconds on this model. What we've got here is a model idea to help us select out those functions that ought to be automated and those functions that ought to be assigned to the man in some kind of a rational way. The first order of business in this model is to ask ourselves, what are the tactical activities? And we are dealing in the tactical portion of the mission, and so we answer the question, yes, we are dealing with tactical. These are all tactical activities, all right? There are other activities like takeoffs and landings and ILS approaches that are not tactical activities that would have another model that we would go to, okay? This model is just, we think, appropriate for tactical activities. We would ask ourselves then in block 3, what is in fact a decision required? What's a decision processing? If a decision is not required, then it falls out and goes to block 6. If a decision is required, we've got to stop for a second and ask ourselves, okay, what kind of decision? We covered this morning, right? Is it a type 1 decision or is it a type 2 decision? If it's a type 1 decision, then that falls out into the man side. If it's a type 2 decision, we continue Good. We got type 2 decision, and you saw today that our task 6.1.1 was considered to be a type 2 decision, right? So it's still a candidate for automation. So we continue, and we ask ourselves other things about this task and this function that represents this task. Is concept application involved? What other processing is involved here? All right. Do you have to recall facts? Do you have to apply a concept, a principle? What's going on here in a processing sense? And we get some idea of how we're going to deal with this function at the system level. And let's say that everything is fine, and we come out here and we specify our available technologies. What technologies are we going to bring to bear here? Now we start to begin to look at the technologies in a kind of a general sense. We do know what the technological capabilities are because we're part of industry. This is a model, this is a little bit more detailed model of this one here, but they both represent the same thing. What we get down to is this box right here. Specify automatic functions and assess the utility of each. Now we've got one more step to go through here, we think, and we think it's pretty important. After we have our list of candidate automatic functions, then we ought to look at why do we want to automate them. And we had some good reasons here. But let's assess the utility of doing that automation just for the sake of argument, okay? Because we're not totally convinced that more is better, okay? Okay, so that's our model. That's a very similar model. It's a little bit more detailed. That's the function that we're going to be looking at for the moment. Okay, this is called a tactical planner, or sometimes it's called a mission manager. It's that function in the system that's supposed to be dealing with this area that we saw in the video. Okay, now these are kind of general terms, and they're not. This does not specifically reflect a particular airplane or a particular mission manager. All right, it's kind of it's been generalized and desensitized a little bit. But let's assume that we have decided that that represents our mission manager. And that thing is going to do all the functions. Remember, we haven't assigned them yet, but that baby is going to do all the functions that we need to do in that portion of the mission. And we subject that thing to this analysis to figure out what are the candidates for automation. And then ask ourselves further, what's the utility of automating those candidate functions that seem to be automatable? Is that a real word, automatable? Is it? Is it now? Yeah. All right. Okay, now where are we going next? Go ahead and put that up. And put that up, Graham, and let's see where we are. Oh, this chart, I just wanted to show you that we may have captured potential automatic functions and described them in some way, okay? As either a member of this team or we went out to other people in the company and said, give me the list of automatic functions, sub-functions, and techniques that could be used in a mission manager, okay? And they gave us this. This does happen to come from a Air Force report. Okay, so they said, well, these are the potential automatic functions that we think could be used in the next 10 years. Okay, so we have that in our database. All right, let's put the utility, the next order of business is the utility assessment model. Okay, let's put that up. No, I don't, yeah, that one there, yeah. What we're going to do now is we have this candidate list of automatic functions. Now we're going to try to assess the utility of doing that automation, okay, because we're not convinced that more is better. We want to give it, at least give the customer an idea that there's good, strong rationale for doing this kind of design or for automating these functions within the mission manager. So what we have here is we have a utility assessment model, or a notion of assessing the utility of a function or a group of functions. And the whole idea is very simple. we take whatever that group of functions is that we have selected for our analysis and look at it from two perspectives. And that is, I'm going to put this up over there. Let's put this up. And that is this perspective here. I'm going to look at this model from the perspective of what's the processing efficiency of this candidate automatic function, and what's the potential for workload reduction. Now, obviously, if the man, and we talked about this, right, at the break, if the man has to be in the loop, constantly monitoring the automation that has a lower potential for workload reduction than if you could remove that from the cockpit, for example, right? Okay. Okay, another example. I used to fly an airplane in the Navy that had a center of gravity gauge because we had an aft fuel tank, and if you were in burner for a long enough period of time, you would be out of center of gravity limits, all right? Now, because of technology, we have removed that from the cockpit. We no longer have to address ourselves to center of gravity. So that is a function that's been automated and removed from the cockpit. And I don't even have to think about that anymore as a pilot, and that reduces workload, right? You see what I mean? Okay. Now, if you could build an impulse engine that doesn't use fuel, and if you could remove the fuel gauge from the cockpit, and I don't even have to worry about fuel. I can stay in burner forever, or until I get tired, right? You've automated that function. You have reduced workload, right? Okay? So that's the idea here. Potential for workload reduction, I think, is important. We need to look at that. What is the potential for workload reduction? Does this thing make sense from that standpoint? And also, we need to make sure that we are, in fact, processing the mission essential information that needs to be processed. Some designs don't do that and claim to, so we've got to be careful. All right, let's look at this one here. And we're going to analyze this. In this example, we have information requirements or information elements in our processing. This is our automatic function that we've described here in a little bit more detail, but that's our automatic function. And we notice that we can, just hypothetically now, stay with me, we can process 3 out of 4, or we have a processing efficiency of 75%. So that function, that automatic function, relating that to the mission requirements or the information requirements, mission essential information, that can process at an efficiency of 75%. Now, I don't know where the cutoff is yet. Okay, maybe 100% is the cutoff, but I'm not sure. But let's assume that we've got 75% and we all agree with that. It can't do the last one. Okay, but it can do everything else. Okay, now what is the potential for workload reduction? We just saw processing efficiency, right? Now we need to know, we'd like to know, what's the potential for workload reduction? And we've got a cute little scale here. Again, if we can go from action to transparent, remember the center of gravity example that was in the F-11 that I flew. We went from action, I had to take an action. If it was out of center of gravity, I had to turn on a fuel pump, as it turns out, okay, to get the fuel from the aft cell to the forward cell. We went from action to crew transparent. We've reduced work of high potential for workload reduction, right? Conversely, if we go action to monitor, let's say that we have built an automatic system that takes the man out of the loop, but he needs to monitor it, and real-time intent initiation is needed. In other words, he needs to tell it what to do when he wants to do it. Okay, he's got to be able to push the button and say, okay, now, for example, the auto throttles. When he gets to cruise, he's got to be able to say, okay, auto throttles, because you haven't the foggiest idea where I am, You don't know if I'm at 1,000 feet or 35,000 feet. Please go to cruise power now. Okay, real-time intent initiation is needed. Okay, the potential for workload reduction in that case is less. Agree with that? Okay? You don't agree with it? Yes, yes. Okay, I think that's fairly self-evident, all right? Problem in the cockpits today, as expressed in a number of reports, is that we've got a lot of monitoring going on. And the human is not a terribly good monitor, okay, from our psychology training, right? We have people that have studied that subject here? Yes, no, yes. The human is not a terribly good monitor, all right? So what we want to do then, if we can do this in our design, we want to get up here. We want to go to crew transparent if we can, or we want to make sure that, go ahead.
I guess I'm a little confused. You're saying one of the candidates would be automating something, but it would need to be monitored. Is that it?
If required.
That's right. This utility would be very limited.
There would be less. That's right. That's right. Exactly.
You could make it transparent, but that's not the candidate you're proposing now.
If you could make it transparent, then you would reduce.
If you had a flight management system.
Right. Right. You may not be able to for various reasons. Okay, the technology limitations, doctrine, okay, military doctrine, okay, whatever, okay. You know, there will be a man in the loop here, okay? Now, obviously, if you built an RPV that could do this, all right, we then have everything that's gone to, there's no crew there. Everything is transparent to the crew, okay? And from a crew standpoint, then, we've reduced workload. All right. Taking that function example that we saw, 75%, combining that with the potential for workload reduction. In that case, now, it was low because the man was still required in the loop because of various reasons and doctrine. Okay, he was still involved with prosecuting the target. He was still making decisions to shoot. Okay. The utility fell pretty low on the utility scale. It was 75% times 10, which is 7.5, pretty low. So the potential for workload reduction was low, even though a lot of things could be processed autonomously. We still don't have a high utility here for automation. So that needs to be considered in our design, all right? And I'm not saying that we drop the notion at this point, but we consider that. And let's look at our tactical planner here, or our mission manager. And we did that. This is a hypothetical case now, okay? But we did that for the mission manager or tactical planner. We looked at all of the sub-functions, and we did a utility analysis of each. Now, some are going to be mandatory because you see two there, 6.2.2 and 6.2.3. Those are, in fact, type 1 decisions. Those are mandatory assignments to crew. They fell out real early in our model. Others, we see, are very low utility. Okay, those would then probably go into the man bucket. The other, there's some gray areas here. All right, you got some 20s and 30s. Don't know exactly what to do with those. You got some 50s, which are fairly high. And then you got, what do we got? A couple of, two 100s, all right? So clearly we got some that ought to be automated. Okay, we think that we've got some, you know, good payback for doing that. Some that clearly ought to be allocated to the man. And we have some in between.